Okay, welcome to another section of our revision class. I believe you must have seen the other classes like the Maths 101, the Practical Chemistry, Physics, and others. Okay, today is the introduction for the Physics 101 online revision class for the examination that is set to start on the 24th of April 2024. Okay, so like I said, I'm always going to do. I'm going to be taking it bit by bit, mostly trying to revise the past question. Now, the way I'm going to take this physics revision class is the way that the Spirit have directed me to do so. So please just follow me suit and you will never regret you took this class, okay? The aim of this revision class is to bring to our knowledge what we are supposed to know, because the same information is power, what we are supposed to know and have in mind for the forthcoming examination. Okay, if you observe, I believe you have your own past question with you on Physics 101, so we are going to kickstart now. So I'll be taking the questions and be revising it. I believe that you have subscribed to this channel and you have liked the videos. Please try and do that so that you can support this movement. Thank you and God bless you. So we start from number 1, 2020, Physics 2020, 2021. 2020, 2021. Okay, we kick off. The first question here says, in an adiabatic process, they say option A, heat is lost. Option B, heat is gained. Option C, heat is transmitted. Option D, no heat is exchanged. Now, first of all, for you to be able to answer this question, you must know what is an adiabatic process. Let's take this thing. Adiabatic process or adiabatic condition, you can take this down. An adiabatic process or adiabatic condition is a condition of constant heat. It's a condition of constant heat. That is, no gain or loss of heat. The system does not gain heat, does not lose heat. So adiabatic condition or system is a system of constant heat. There is neither gain of heat nor loss of heat to the surrounding. Okay, we have to also note that when the pressure and volume of a gas changes under constant heat, the change is said to be adiabatic. I repeat, when the pressure and the volume of a gas changes under constant heat, that change is said to be an adiabatic change. That change is said to be an adiabatic change. Are we there? Okay. There is something I would like to show us. Okay, having observed that adiabatic system is a system of constant heat, and also I also ask us to note that when a pressure and volume of a gas changes under constant heat, such change is said to be adiabatic. Now, there is something we call adiabatic bulk modulus. There's something we call adiabatic bulk modulus. We want to look at the relationship between adiabatic bulk modulus and adiabatic pressure. Adiabatic bulk modulus K is equals to pressure gamma. This is the relationship between adiabatic bulk modulus and adiabatic pressure, where this guy is Cp over Cv. This guy is Cp over Cv. Please note this, or still under adiabatic should the question arise like this. So we have K equals to P, Y, where K is adiabatic bulk modulus and the P is adiabatic pressure. So the relationship between adiabatic bulk modulus and adiabatic pressure is not directly equal, but this is their relationship, where this guy you're seeing here, like it's like a Y, is Cp over Cv. What is Cp? This is molar heat under constant pressure, and this is molar heat concentration under constant volume. Molar heat concentration under constant pressure, molar heat concentration under constant volume. Let us observe a question that has come out under this aspect before, so that we can drive this point to should you sit in the exam. you will know what we are trying to talk about. Okay, if we look at the example on the board, this example is a calculation on the adiabatic process. It says the molar heat of capacity of a gas at constant volume is this, and molar heat capacity at constant pressure is this. They now ask us to calculate the adiabatic bulk modulus of the gas at pressure of 1 atm. Now look at our solution. Our CP, which is molar heat capacity at constant pressure, is this. Molar heat capacity at constant volume is this. Then remember that our gamma, or we call it Y, is CP over CV, which we have got here. Now, if your pressure is given in atm, you must always convert it to Newton per meter square. And the relationship is that 1 atm is equals to 101,325 Newton per meter square. Assuming the atm here was given like 5 atm or like 2.5 atm, you have to do the conversion. 1 atm equals to 101,325 Newton per meter square. Therefore, 2.5 atm equals to x. That is if the atm given here was 2.5. So you have to convert your pressure to Newton per meter square. Now, remember that we said that adiabatic bulk modulus and adiabatic pressure is related like this. So this question says we should calculate the adiabatic bulk modulus K. So K is equals to adiabatic pressure times the gamma. So, and we have got the gamma to be this, and we have the pressure to be this. So if you multiply both of them, you will have this. This is another question on the adiabatic process. So, like we said, adiabatic process is a process of constant heat. That is, in that system, heat is neither gained nor what? Lost. We go to question number 2. This one is question number 1. We go to question number 2. Okay, where we have an adhesive liquid dash. Okay, if you look at question number 1, you see that the option that we go for it is heat is lost, no. Heat is gained, no. Heat is transmitted, no. So we have option D, no heat exchange. So that one goes for question number 1. Number 2, an adhesive liquid, A, does not wet other substances. B, has a convex meniscus. C, has capillary fall. D, has concave meniscus. Now, for us to understand this question better, we need to know what an adhesive liquid is. We need to know what an adhesive. I repeat, adhesive force is a force of attraction between molecules of a substance and molecules of another substance. Force of attraction between molecules of a substance and molecules of another substance. Are you there now? So, adhesive force is a force between molecules of a substance and molecules of another substance. Let's see something. Liquid in which adhesive force is greater than cohesive force tends to wet glass. That means we have liquids have these two type of force, adhesive and cohesive. So in a liquid where the adhesive force is greater than the cohesive force, such liquid tends to do what? To wet glass, or you can say to stick to glass. They also have concave meniscus. Now, liquid whose adhesive force, when adhesive, is greater than cohesive, 1, it will wet glass. 2, they will have concave meniscus. They will have concave meniscus. Any other information? So, example of liquid that behave like this, we have water. Water is an example. Kerosene is an example. Water is an example. Kerosene, petrol is an example. And so much. Now, these are liquids that, example, when we say water is an example, listen. When you finish, if you put water inside a can or a plate or whatever it is, when you turn the water out, you still see some water molecules still sticking to that. So that's what we call adhesive. They adhere to the surface of the. So let's go back to the question and see what option likely works out now. Let's see. So we says an adhesive liquid does not wet other substances. Wrong. They wet glasses. Has a convex meniscus. Wrong. Their meniscus is concave. Has capillary fall. No. Has a concave meniscus. So our option D goes for number 3. Number 3 is option D. We go to number 4. Okay, number 3. Number 2 is option D. We go to number 3. A tangential force of 0.005 Newton applied on a solid surface of area causes a deformation through an angle of 0.007 degree. Calculate the shear modulus. Now, this question talks about shear modulus. This topic is under elasticity. Peradventure you don't know where this topic came from. It's under elasticity and it's talking about shear modulus. Let us take some information about shear modulus. Now, you will observe that shear modulus, also called modulus of rigidity, is given by the formula shear modulus G is equals to F over A theta. Shear modulus is F over A theta. So if we have this as a formula for shear modulus, then look at what the question is saying. It says a tangential force, that means F is equals to 0.0005 Newton. Then applied to a solid surface area, they gave us area as 20 centimeter squared. Okay. Caused a deformation through an angle. They gave us the angle to be 0.007 degree. Now say calculate the shear modulus. We are calculating for shear modulus. So what is here is that this is the only place that there is work here. We are going to convert 20 centimeter square to meter square. We're going to convert 20 centimeter square to meter square. How do we do that? 20 divided by 1000 squared. So we want to convert centimeter square to meter square. We're going to divide by 100 squared. So this becomes meter squared. So converting centimeter square to meter square is this. So at the end of the day, it is 0.0005 over A is what now? 20 over 100 all squared times 0.007. And whatever you get there gives you your shear modulus, or you call it modulus of rigidity. Okay, let me see if there's any other information I have for us there. Okay, I've told us that this topic is under elasticity and I've given us a formula. I think that is all. We go to number 4. Number 4 says the surface tension on a soap bubble. The surface tension on a soap bubble is 20 Newton per meter. Okay. The noun says, and the diameter is 30 centimeter. Calculate the excess pressure inside the bubble. Excess pressure inside the bubble. This topic can be seen in fluid mech. Now, let me give us some information before we can calculate excess pressure inside the bubble. Pressure inside the bubble. Now, this topic falls under fluid mechanism. You want to go and read it up. Now, it can come in two forms. They can ask you to calculate the excess pressure inside the liquid drop or excess pressure inside soap bubble. Now, excess pressure I inside liquid drop, and we have II inside soap bubble. These are the two types of pressure you can have in that fluid. Inside the liquid drop and inside soap bubble. So if you are to calculate excess pressure inside the liquid drop, pressure is equals to 2y over r. Why this one is pressure is equals to 4y over r. So you are master this thing where this one is called the surface tension. Okay, and this is radius. So let's now, with this example now, let's see if we can solve what they are talking in question number 4. It says the surface tension on a soap bubble is 20 Newton per meter. So surface tension, the Y is 20 Newton per meter. And the diameter is 30 centimeter. Diameter D is 30 centimeter. Calculate the excess pressure inside the soap bubble. Now, they gave me, I'm looking at excess pressure inside the soap bubble. I don't have. Surface tension is 20 Newton per meter. Why diameter? Remember that half a diameter is radius. What we have here is radius. So, first of all, you convert centimeter to meter. You have 30 divided by 100. Converting centimeter to meter, you see 30 divided by 100. That will give me 3/10 meter. So, then my pressure here now becomes soap bubble 4y over r, which is 4 times y is 20 over r, which is 3/10 meters. Whatever you get here becomes your final answer. So if you calculate that, you are going to get whatever is there. So please mark this. When you have excess pressure in fluid, there is excess pressure inside the liquid drop. There is excess pressure inside the soap bubble. Okay, we move quickly to question. It says John dived into a deep swimming pool to swim, but sank to the bottom. This is because, okay, we are going to know why John sank. Let us take few information about this. That's question number 4. This topic falls under fluid mechanics also. That is question number 5. This topic falls under fluid mechanics also. Now, I want to give us some instruction about this. Number 1, when an object is completely immersed in a fluid, it displaces amount of water equals to its own volume. Note that. When an object is completely immersed or even partially immersed in a fluid, it will displace an amount of water equals to its own volume. Note that, 1. Another thing you must note there is that when an object is partially or completely immersed in a fluid, it will experience an upward force. This upward force is called upthrust, and it also experiences apparent loss in weight. When you completely or partially immerse an object inside a fluid, the object will experience an upthrust, an upward force, as if something is pushing it up. That upward force is called upthrust. Now, and the object will also experience loss in weight. It will look as if it has no weight anymore. Just like if you want to, those that fetch water from well, when you have the bucket in your hand, you throw it inside the well. When the bucket goes deep into the well, it will look as if the bucket is now weightless. That is that object. Inside the fluid, 1, it will experience an upward force, a force trying to push it up. If you go for swimming pool to swim, when you enter inside the water, it will look as if your leg is not touching ground. Yes, because of the upward force you are experiencing. This upward force is called upthrust. Now, also, another thing that will happen to that object inside the water, it will be exhibiting weightlessness and apparent weight. Apparent weight is called false weight. It's not the original weight. So it will also experience an apparent weight inside the water. Observe that. Now, number 3 is that upthrust. Upthrust, since we say it's going to experience an upward force, and this upward force is called upthrust. It's going to experience an upward force. This upward force is called upthrust. Now, what is upthrust? Upthrust is apparent loss in weight. Upthrust is the same thing as apparent loss in weight, as if the thing has lost weight. Then, how do you calculate apparent loss in weight? It is now the weight in air minus weight in water. That will give us the apparent loss in weight. So, upthrust, another thing you must, upthrust is equal to apparent loss in weight, and apparent loss in weight is false weight, which is weight in air minus weight in water. Another thing we need to understand here is that upthrust is directly proportional to the density of the fluid. Upthrust, keep these informations. Upthrust is directly proportional to the density of the fluid. So if the density of the fluid increases, upthrust will also increase. If the density of the fluid increases, upthrust will also increase. Remember where we came from. We first of all established that when an object is partially or completely immersed in a fluid, it will displace amount of water equal to its own volume. That's one. And when an object is partially or completely immersed in a fluid, that object will experience an upward force. This upward force is called upthrust. And that object will be exhibiting a situation of weightlessness, or we call it apparent loss in weight. Apparent loss in weight can be calculated by minusing the real weight in air minus weight in water. Now, we also observe that upthrust is directly proportional to the density of the fluid. That means as the density of the fluid increases, upthrust will also what? Increase. That means then fluid that have high density tends to have high upthrust. Okay. The next one we need to observe here is Archimedes' principle. What does Archimedes' principle say? All these things are things that you need to know in this topic. Archimedes' principle says that when an object is completely or partially immersed in a fluid, it experiences an upthrust equals to its own weight of fluid displaced by it. It will experience an upthrust. This upthrust is equals to the amount of fluid this object has displaced. So I repeat, Archimedes' principle states that when an object is partially or completely immersed in a fluid, it experiences an upthrust, which is equal to the weight of the fluid displaced by this object. So when you put an object inside a fluid, the object will goes into the fluid, it will displace some water. The weight of that water displaced is equal to the upthrust acting on that object. I don't know if you understand. Just get a bowl and take something like ball. Try to dip the ball inside the water. Then you see that the water will overflow. If you carry that one that overflow and measure it, it is equal to the upthrust acting on that object. That is what Archimedes is saying. Okay. So according to Archimedes, upthrust is equals to weight of fluid displaced. What's that? Upthrust is equals to weight of fluid displaced. According to Archimedes, it's trying to tell us that when an object is partially or fully immersed into water, that it will experience an upthrust. That object will displace some water. That the upthrust acting on that object is equal to the weight of the water displaced. Okay? So upthrust now, mathematically, upthrust is equals to weight. Upthrust is equals to weight. So upthrust is equals to mg. Mathematically, upthrust is equals to what? Mg. Now, the next thing we are going to note is law of flotation, or we call it buoyancy. Law of flotation, or we call what? Buoyancy. Let's see. What does it take an object to float? What does it take an object to float? If there is a law, you can see ship, cargoes, they sail on water, canoe, boats. Why are they sailing on water? What does it take an object to float? Let's see. The law of flotation states that for an object to float, the object must displace a weight of the liquid that will be equal to its own weight. For an object to float, the weight of liquid displaced by the object must be equal to the weight of the object. If this condition is met, then that object will float. Again, the weight of the liquid displaced by the object should be equal to the weight of the object itself. That is the law of flotation. So it means that weight of liquid displaced is equals to weight of object immersed. Weight of object immersed. So you see, if the weight of liquid displaced is equal to the weight of object immersed, then this object will float. That is the law of flotation. So if you watch this question was asking us about the law of flotation. Though we have from there talked about upthrust and every other thing. So let's go back to our question and see if we can really answer the question now. Question number 5. It says, John dived into a deep swimming pool to swim, but he sank to the bottom. Why is it that John did not float? This is because 1, the pool was deep. No. B, the density of the water was less. No. C, the weight of water displaced was less than his own weight. The weight of water displaced was less than John's weight. That should be why John sank. Then D, he says he had bad luck. No. Why John will have sunk is that the weight of water displaced by John is not equal to the weight of John. So that is why John will sink. Because why? John did not obey the law of flotation. That's number 5. So we're going to look at one question that will help us solve out this, so that when we sit in the exam, it will be able to be, we'll have been able to understand properly about Archimedes' principle, law of flotation. Okay, let's see this example. It says a 300-gram wood floats. Now, for this wood to float, it must have displaced weight of fluid that is equal to its own weight. So a 300 gram, this is mass of the wood, not the weight of the wood now, floats on a liquid of density. This is the density of the liquid. And now say, calculate for question 1, what is the volume of the fluid displaced? They are asking us for the volume, not the weight. So, but you know that for the wood to have float, it has displaced the volume of the fluid that is equal to its own weight. Now, number 2, they say we should calculate the upthrust on the wood. Remember that Archimedes' principle says that when an object is partially or fully immersed in the fluid, it will displace the volume, or it will displace the amount of the fluid that is equal to its own weight. Now, for this wood to float, you know, law of buoyancy or flotation is involved. Now, look at the solution. The mass of the wood is 300 grams. You convert gram to kilogram. We already have that. So, now, the weight of the wood, if I know the mass of the wood, remember that weight is mass times g, which is mg. It gave me 0.3 kg times 10 meter per second, which will give me 3 Newton. Remember, they asked us to take g as 10 here. Now, the weight of the fluid displayed is equal to the weight of the wood. Hope you know, for it to have float, because of it floated. So, the weight of the fluid displaced will be equal to the weight of the wood. So the weight of the fluid displaced is 3 Newton, while the weight of the wood is also 3 Newton. So therefore now, we want to find the mass of the wood. Remember the question says you find volume. And for us to get volume, we can only have that density is equal to mass over volume. We have the density of the fluid, which is given to us here. We have the question says we should find volume. We don't know the volume, but we have the mass of the fluid, we say to find the volume of the fluid displaced. So we have density of the fluid. We need to look for the mass of the fluid, which we can get because we know the weight of the fluid. How do we know the weight of the fluid? Remember that the weight of the fluid displaced is equal to the weight of the wood. So if I know the weight of the wood, since weight is m times g, F is equals to m times g, or you say weight is equals to m times g. If I know weight, look at what we are trying to say. Weight is equals to m times g. So if I know weight and I know that g is constant, I can always get mass. So since I'm talking about the volume of the fluid displaced, it is equal to the weight of the wood. So for me to get the mass I'm looking for, I will have the weight 3 Newton and I have 10, so I can look for mass. So that is why we do the mass of the fluid is 3 Newton divided by 10, which will give us 0.3 kg. So we have got the mass of the fluid. So from density is equal to mass over volume. Volume of the fluid becomes, if you make volume sort of the formula here, we have mass of the fluid over the density of the fluid, which is this, and it gave us this. So this is the volume of the fluid. So anytime they ask you to calculate volume of fluid, always use this formula that density is equal to mass over volume. Density is equal to mass over volume. Try to find your mass, trying to find the volume, and the density will always be given. So you know that your mass can always come from weight is equal to mass times G. You can always get your mass there. This one is a constant, and they will give you weight. You find the weight of the fluid, or if the weight of the object. Once you know the weight of the object, G is already known. You can always get your M from it, so that you can get your volume. Also, the question we should calculate upthrust. Remember, upthrust is weight. Upthrust is equal to weight of the fluid displaced. So upthrust is equal to weight, and weight is mg. So upthrust is mg, which is 0.3 times 10, which will give us 3 Newton. Remember that upthrust, the upthrust is that force, upward force that is being experienced by the object that is being immersed. And we say that it is equals to the weight of the fluid displaced. It is equals to the weight. Weight of the fluid displaced is 3 Newton. So upthrust is always equal to the weight of the fluid displaced according to Archimedes. According to Archimedes. So this is one example. Let's look at one more example that deals with flotation, so that anyhow question comes under this Archimedes principle, we can always be sure to be able to answer it. Okay, if we watch this another example, it says a wood of volume 20 centimeter cube. That's the volume of the wood. And density of the wood is 5 grams per centimeter cube. Is dropped inside a liquid of density. This is the density of the liquid. The next we should determine if the wood will float. Now, there is something I want to tell us. First of all, for this wood to float, the weight of the wood must be equal to the weight of the water displayed, or the weight of the fluid displayed, according to the law of flotation. So what I need to calculate for is, I want to know the weight of the wood. Then I also calculate for the weight of the water displaced. If they are the same, then I can answer that this wood will float. But if they are not the same in any respect, then the wood will sink. So the first thing is to calculate for the weight of the wood. What are the information given to me? I have the volume of the wood is 20 centimeter cube. Now, you must know that for them to have measured the volume of the wood to be 20 centimeter cube, Archimedes' principle says that when an object is partially or fully immersed in liquid, that it will displace a volume of liquid which is equals to its own volume. So if the volume of the wood is this, also now the volume of the liquid displaced will also be 20 centimeter cube. Now that is one. Volume of the wood is this. Now from density is equals to mass over volume, we can get the mass of the wood. Since we know the volume of the wood, we can get the mass of the wood. Now mass of the wood will now be density of the wood times the volume of the wood. So density of the wood times the volume. Watch, gram per centimeter cube. So it's given in gram times this will give us 100 gram. We're going to convert 100 gram to kilogram. So this becomes the mass of the wood. If I know the mass of the wood, if I multiply the mass by 10, which is associated to gravity, it will give me the weight. Remember that weight is equal to mg. So weight of the wood is 0.1 times 10, which will give me 1 Newton. Now, I now know the weight of the wood. I will also look for the weight of the fluid displaced. Let's go there. Volume of the fluid displaced is still 20. Now, mass of the fluid displaced. If I know the volume of the fluid displaced, I will come and say mass is going to be density of the wood times the volume. They gave me the density of the wood. So it's going to be density times volume, which will give me 8 gram. Convert 8 gram to kilogram, give you 0.008 kilogram. Now, if I know the mass of the fluid now displaced, to calculate the weight of the fluid, I'm going to multiply this one by 10, which I have the weight of the fluid displaced equals to 0.008 kilogram times 10, and which will give me 0.08 Newton. So this is the weight of the fluid displaced. Why this is the weight of the wood which was deep into the fluid. If you observe, the weight of the fluid and the weight of the wood and the weight of the fluid displaced are not the same. This is 1 Newton and this is 0.08 Newton. Hence, this wood will sink. According to the law of flotation, this wood will what? Will sink. I believe that is very clear. So we go back to our question now. Remember that in that question number 5, they did not ask us any calculation, but I just put up this should. Any calculation comes up anytime, we might jump that. So John dived into a deep swimming pool to swim, but he sank to the bottom. This is because the weight of John and the weight of fluid displaced is not equal. That's why John must have sinked. Number 6, calculate the viscous force of liquid of a surface area 5,000 centimeters square flowing with a velocity gradient of 0.8 per seconds. Okay, they gave us coefficient of viscosity to be that. Now, this one is talking about viscous force. Viscous force. Is there some information we need to take about viscosity? Yes. Let me give you some information about viscosity. First of all, I will start by defining what viscosity is, or what type of liquid is called a viscous liquid. Now, viscosity is the force that opposes the motion of one layer of a fluid over the other. A force that opposes the motion of one layer of the fluid over the other. I can simply say that viscosity is that force that prevents a fluid to flow easily. Sometimes when you want to pour, if you pour out water from a cup, you see the way it flows very easily. It's because water has a very low viscosity. But if you bring something like grease and you want to pour it out of its container, it is very difficult to flow. That means that the grease has a very high viscosity. So that force that prevents a liquid to flow easily is called viscous force. So viscosity is the opposition to the flow of what? Layer of liquid over the other. Okay, we have gotten that. Let's also know that viscosity of a fluid is directly proportional to its density. That's another thing you have to note. Viscosity of a fluid is directly proportional to its viscosity of a fluid is directly proportional to its density. Viscosity V is directly proportional to density, and viscosity is inversely proportional to temperature. Viscosity is inversely proportional to temperature. Let me explain this. The density of a fluid. The denser a fluid, that means the more heavy a fluid, the higher its viscosity. Like grease is more heavy than water, so grease has higher viscosity. If you get an original honey comes from the honeycomb, is very, very thick. When we talk of this viscosity, what we are even trying to say there is thickness of the fluid. The more thick the fluid is, that is the density, the more the viscosity of that fluid. Now, the relationship between viscosity and temperature is that viscosity is inversely proportional to temperature. It means that when the temperature of the fluid increases, viscosity reduces. But when the temperature reduces, viscosity increases. Now, let me tell you something. If you have an engine oil, you see when you buy it new, it doesn't flow like water. But when you have put it into your generator or your gadget, after a while, if you pour it out, it starts flowing like water. It means that temperature has reduced the viscosity, because while you are running that gadget, the temperature of that gadget is increasing the temperature of the system and the environment where the oil is. So as the temperature is increasing, viscosity of that oil will be reducing. That is why we say that viscosity is inversely proportional to what? Temperature. That means as temperature is increasing, viscosity of the fluid is reducing. While as temperature is reducing, viscosity of a fluid will also what? Increase. That is another last one. Now, I want us to know that viscosity of a fluid, the viscous force, is calculated as F is equals to this A dy over dv dy, dv dy. If you are asked to calculate the viscous force, you're going to use this. Where this is coefficient of this one is coefficient of viscosity. This one is coefficient of viscosity. This one is area, and this one is velocity gradient. Coefficient of viscosity, area, velocity gradient. Okay. Now, there is something I want us to also learn quickly. Stokes law. Stokes law is very important in this topic also. Stokes law. Now, Stokes make a very great remark in his law. So let us see. According to Stokes law, it states that when an object such as steel ball, when an object such as steel ball is dropped inside a viscous liquid, when an object, I'm stating Stokes law states that when an object such as steel ball is dropped inside a viscous liquid, example, engine oil, the object will accelerate down at first and finally reach a steady velocity with which it continues to move. This steady velocity is called terminal velocity. Now, Stokes is trying to say that when you have a steel ball, you have an engine oil which is very highly has high viscosity. If you take the steel ball and drop inside the engine oil, the steel ball will travel down, accelerate down. After a while, it will now start moving with a constant velocity. That constant velocity is what we call terminal velocity. Now, this terminal velocity and the viscous force is related by this formula. Viscous force is equals to 6 pi r, coefficient of viscosity, then V, which is terminal velocity. So that terminal velocity V is now viscous force over 6 pi times coefficient of viscosity. So, okay, R, then coefficient of viscosity. So please master this. You can write it down. Write this down. This is the relationship between viscosity and terminal velocity. And this formula, direct formula for calculating the terminal velocity. And we have heard what Stokes law have to say. So having got this information, we go back to the question. Question say calculate the viscous force. Okay, this one says we should calculate, so we are going to be using this formula. Okay, viscous force, not terminal velocity. Calculate the viscous force of a liquid of surface area 500 centimeters square. Area 500, is it 500 there? Area is 5,000 centimeters square. And flowing with a velocity gradient of 0.8. So we have velocity gradient, dv dy is 0.8 per seconds. Okay, so if I'm to calculate, remember that I have my F to be equals to minus, please, there is a minus there if I've omitted there, minus a dv dy. I didn't say something about this minus. This minus shows that this force is a restricting force. It's going back. It's a negative force, not a positive force. So it means that all our answer must carry this minus. So all our answer must carry this minus. So they gave me coefficient of viscosity there. They must have given me coefficient of viscosity there, which is 6 Newton. They gave me coefficient of viscosity here. I have 6 times area. You are going to convert this to meter square by dividing by 5,000 over 100 squared. So we have 5,000 over 100 squared, then times velocity gradient, which is 0.8. So if I do this times this times this, I believe I'm going to get my answer there, which will give me viscous force. As the question says, calculate the viscous force. So the viscous force is got in there. Remember, it must carry minus, okay? Remember, it must carry minus. So this is what we need to know about viscosity. Remember, I've already stated Stokes' law. Okay, we'll continue. The next one is question number 7. It says collision. A collision is defined as elastic if, for you to be able to answer this question, you have to know what collision is and types of collision. So let's take a little information about that. Okay. You have to know that there are certainly 3 types of collision. There are certainly 3 types of collision. Number 1, elastic collision. Elastic collision. What do we need to know about elastic collision? For elastic collision, total energy, kinetic energy, and momentum are conserved. So in this type of collision where the total energy, kinetic energy, and the momentum is conserved, is a elastic collision. What else do you need to know about elastic collision? Coefficient of restitution, coefficient of restitution, which is noted as E. Its coefficient of restitution is equals to 1. That is E is equals to 1 for an elastic collision. Coefficient of restitution is equals to 1. An example is collision of two spherical balls. Collision of two spherical balls. So for a collision to be elastic, the condition is that the total energy, the kinetic energy, and the momentum are what? Conserved. Then the coefficient of restitution E is equals to 1. Okay, let's see another type of collision. Inelastic collision. There is elastic collision, there is inelastic collision. Let's see that. For inelastic collision, total energy, comma, momentum, these two are conserved, but kinetic energy is reduced. For inelastic collision, total energy, momentum is conserved, but kinetic energy is reduced. Okay. The coefficient of restitution, now what's something now? Coefficient of restitution is less than 1. That is, coefficient of restitution E is less than 1. When this inelastic collision is referred to as a partially inelastic collision, partially inelastic. But E is equals to 0 for total or perfectly, let's use the word perfectly, inelastic. So when you come to inelastic, there is partial inelastic, there is perfect inelastic. For both of them, total energy, momentum is conserved, but the kinetic energy is reduced. Now, coefficient of restitution for partially inelastic is less than 1, while for perfectly inelastic is equals to 0. Okay. The third one is explosive collision. Explosive collision. For this one, total energy and momentum are conserved. Total energy, momentum is conserved, but kinetic energy is increased. It's different from this one. In this one, kinetic energy is reduced. Why for explosive collision, kinetic energy is increased. Kinetic energy is increased. And the coefficient of restitution for explosive collision, we saw that E is greater than 1. E is greater than 1. For explosive collision, E is greater than 1. Example of explosive collision is bomb explosion. Okay. Example of explosive collision. So we have seen 3 types of collision. We have elastic collision. We have inelastic collision. Inside inelastic collision, there's perfectly inelastic and partially inelastic. Then we have explosive collision, and we have seen their conditions. So when we go back to the question now, I think we may be able to answer the question. Question number 7 is, a collision is said to be elastic if 1, the total energy after collision is equal to that before collision. No, there is no loss of kinetic energy. I don't know. See, both momentum and kinetic energy are not conserved. No, they are conserved. They are conserved. Both momentum and kinetic energy are not conserved in the collision. No. He said the coefficient of restitution is equals to 0. Coefficient of restitution for elastic collision is equals to 1. That one is not part of it. So we are going to go for total kinetic energy after collision is equals to equals to that before collision. Total kinetic energy is conserved. So kinetic energy before the collision is the same kinetic energy after the collision, because total energy, kinetic energy, momentum are all what? Conserved. So option A says the total kinetic energy after collision is equal to that before collision. Option B says that there is no loss in kinetic energy. there is no loss in kinetic energy. Okay, total kinetic energy is equals to after kinetic energy. Yeah, but this one says there is no loss in kinetic energy. I think option B is more correct. Kinetic energy is conserved. There is no loss in kinetic energy. There is no loss in kinetic energy. I think we go better for after the collision. There is no loss in kinetic energy after the collision. There is no, I think that is no. Okay. Option B said there is net loss. Option B said there is net loss. No. Remember that there is no loss in kinetic energy. So option A is more appropriate. That says total kinetic energy after collision is equals to the one before collision. But B says there is net loss. That means there is loss in kinetic energy, which is wrong. So option C, both momentum and kinetic energy is not conserved. No, they are conserved. So you see that option A is the appropriate answer there. So we move to another one. In this case, number 8. The question says, okay, question number 8 says, which of the following is not a type of potential energy? Option A says sound energy. B say elastic energy. C say electrostatic energy. And D say gravitational energy. First of all, we must know that gravitational energy is a type of potential energy. Mark that. Electrostatic energy is a type of potential energy. And elastic energy is a type of potential energy. The wrong option there is sound energy. Sound energy is not a type of potential energy. You can see this in your textbook when you go to the topic called conservation of momentum. Conservative and non-conservative forces. In your textbook, go and read it up. You will see that there. So we have satisfied that number 8 question. The answer is example. We move to question number 9. The rate of change of angular momentum of a particle is equals to, the answer to that question is torque. Let's see information about torque. What is torque? Let us define torque. I say the answer to that question is torque. Option A. What is torque? Torque can be defined, torque, that is option A. Torque can be defined as the rate of change of angular momentum with time. Torque is defined as the rate of change of angular momentum with time, where L equals to angular momentum. So torque is the rate of change of angular momentum with time. Torque is the rate of change of angular momentum with time. So that question is which of the following is not, no, number 9 says the rate of change of angular momentum of a particle is equals to what? Torque. Torque is the rate of change of angular momentum. Now, I want us to learn some things about this angular momentum. Let us take some few examples under this angular momentum. Should something comes out under angular momentum. We want to learn some things about angular momentum. I have 3 things I want us to know about angular momentum. Watch. Angular momentum of a particle. We want to know angular momentum of a particle. The angular momentum of a particle is given as L equals to RP, where L is angular momentum, R is radius, while P is linear momentum. So L is equals to RP is equals to R times mdv. Remember, linear momentum is mdv. So if you are asked to calculate angular momentum, if they will give you the linear momentum, so you just say radius times linear momentum. Or if they didn't give you the linear momentum, they are going to give you the mass and the velocity to work out. Change in velocity, please. This is change in velocity. You can put it change in velocity, or this becomes R times m v2 minus v1, like that. You can also put it like that. Okay, the next one is angular momentum of a rigid body. The angular momentum of a rigid body. We said that the angular momentum of a rigid body is calculated as L equals to IW, where W is 2 pi F. So it's I times 2 times pi F. Now, I is moment of inertia. I is moment of inertia. So if they want to calculate the angular momentum of a rigid body, they will give you the moment of inertia. When they give us the moment of inertia, they also give us the angular velocity, which is 2 pi. So if you multiply moment of inertia times angular velocity, it will give you angular momentum of a rigid body. Okay. Another thing is rotational kinetic energy. Rotational kinetic energy. If you are asked to calculate the rotational kinetic energy, you are going to have that rotational kinetic energy is equals to linear angular momentum squared over 2 times what? Moment of inertia. Now, I want to define for us what do we mean by a rigid body. Let's define what we mean by a rigid body. A rigid body is a body where the particles that makes up the body do not move relative to one another. The particles that makes up the body do not move relative to one another. We call that body a rigid body. A rigid body is a body in which the particles that makes up the body do not move relative to one another. What do we mean here? We mean that the body has a fixed shape. The body has a fixed shape, okay? And all its part has a fixed position relative to one another. Now, for you to say this body is a rigid body, the body must have a fixed shape. Any material you pick up or object you pick up that because of maybe the way you hold it or whatever force apply on it is beginning to change its shape, it takes another shape. That body is not a rigid body. A rigid body has a fixed shape, a definite shape, and the particles of it does not move relative to one another, just like we have learned. Okay, just know that one of the example of rigid body we'll be using here is the earth. The earth is a rigid body. Okay, now rigid body makes two types of motion. Rigid bodies makes two types of motion. Number one, translational motion, and number two, rotational motion. If you watch, the earth makes translational motion and it makes rotational motion. You call revolution and rotation. So a rigid body must make two types of motion, rotational motion and translational motion. So we have got definition of what a rigid body is. Bodies that can be referred to as rigid body, they must have definite shape, and the type of motion rigid bodies can undergo. So we have seen that because we have the angular momentum of rigid body. Here is angular momentum of particles. Angular momentum of particles. We know what particles is. So we also have known what rigid body is. Now these are these are outlines, so that when question comes out under things like this, we can always answer. So we're going to dive into a bit into questions that we can use to solve something like this, so that whenever we see something like this in the exam, we should be sure to have enough. If you look at the board, we're going to see a question. It says the earth moves round the sun in uniform circular motion. If the origin of coordination is placed on the sun, what is the angular momentum? What is the angular momentum of the earth? They gave us that the radius of the earth is this, the velocity of the earth is this, and the mass of the earth is this. Men and brethren, we already know that linear angular momentum is equals to r times linear momentum, which is p, or it is same as linear momentum, which is m times v times the radius. So this is m, this is v, this is radius, and that gives us our angular momentum. Let's look at one more question and its solution to drive this. So we try to look at some another example under angular momentum. This question says that the moment of inertia of the earth about an axis through the pole is this. So this is the moment of inertia. Now say we should calculate the spin angular momentum and also the rotational kinetic energy. So we want to calculate spin angular momentum. So I use this question to teach us about spin angular momentum and also rotational kinetic energy. These are the two things I want to use this question to teach us. One is that, note, spin angular momentum is rotation about an axis every 24 hours. Rotation about an axis every 24 hours is called spin angular momentum. Also, orbital momentum. Orbital momentum is revolution about the sun. So when we talk about orbital momentum, so remember I said spin angular momentum. Another one is now is orbital momentum, revolution about the sun. This is a thing that you need to just know there. So coming to the question proper, you know they asked me to calculate angular momentum, and also so for me to calculate angular momentum, remember that angular momentum, we have already said it before, that L is equals to IW. L is equals to IW. So I need moment of moment of inertia, which they've given to me as this. I also need angular velocity. So for me to get angular velocity, remember that angular velocity is 2 pi f. Angular velocity is 2 pi f. 2 is constant, pi is constant. I need frequency. So frequency is 1 over day. That is converting to day, 1 over day. Because why are we saying 1 over day? Because we say that spin angular momentum is rotation about an axis every 24 hours. So to get my f, I will say 1 over day, which is 1 over 86,400 seconds. 86,400 seconds. So when you are given spin angular momentum, this is how you get your frequency, your f. 86,400 seconds, which will, if you do inverse of this, it will give me this. Now, I haven't gotten my frequency to be 1.2 times 10 raised to power minus 5 seconds. Okay. Then I'm going to be having angular velocity, which is 2 pi f. We have said there, will give us 2 times pi times my frequency, which I've gotten here, This is, will give me produce this. So angular velocity have been calculated. Hence, if I have angular velocity and I have moment of inertia already given to me as 8.1 times 10 raised to power 27, then my angular spin, angular momentum, spin angular momentum, L, will now be L equals to IW, which is now this, which we got from here, times this will give us this. So we have answered the first question, the spin angular momentum. Then the second question says we should calculate for the rotational kinetic energy. Rotational kinetic energy. Rotational kinetic energy is given by the formula. Rotational kinetic energy, Ke, is given by L square over 2I. L square over 2I. That is what we are seeing here now. Do we have L? Yes, because we have calculated angular momentum L to give us this value, 5.9 times 10 raised to the power 33. So we have that. We square it. Then 2 times I. We have I already. Times 2. By the time you do this, you are going to be having 5.9 times 10 raised to the power 33 kilogram dot meter square per second. So this is another example that you need to know about angular momentum. Okay, this is another example you need to know about angular momentum. Okay, and that is question number 9. It says the rate of change of angular momentum of a particle is equals to, like we say, is equals to tau. Tau is the L over the T. Number 10 is a motion of smoke particles from a chimney is typically of. Now, the motion of a smoke from a chimney is called Brownian motion. It's a kind of motion. Brownian motion is a kind of zigzag motion. But let us see what they are talking about here. It says the motion of a smoke particle from a chimney is typically of a circular motion, rotational motion, random motion. Yes, remember it is called Brownian motion. And Brownian motion is a zigzag motion. A zigzag motion is a random motion. If you want to see this type of motion at night, when a car owns the headlamp, you will see some particles moving zigzag randomly. That is what we call the motion. That's what we call Brownian motion, which is the motion of a particle. And that's the kind of motion you see in a chimney gas. A chimney gas is when you see like the school generator has its own chimney, that's an exhaust pipe up. If you go and look at the motion of the particles coming out from there, they are in random motion. So the answer to that number 10 is random motion. Number 11 says a palm fruit dropped to the ground from the top of a tree, 45 meters tall, How long does it take to reach the ground? Okay. A black body is a body that absorbs all the entire heat radiation incidented on it. It is referred to as a perfect absorber or emitter of heat. Okay, that is one thing you must know about a black body. So we go on. The next question is number 15. The amount of heat required to convert 1 unit mass of a liquid into vapor at its boiling point without corresponding change in temperature is known as, that is, latent heat of fusion. Latent heat of fusion. Let's listen to some vital information about latent heat of fusion. We have learned that specific heat capacity is that heat energy that is capable to raise the temperature of a unit mass by 1 Kelvin. To raise the temperature of a unit mass by 1 Kelvin. That one is called specific heat capacity. Now, we also have specific latent heat of fusion. Specific latent heat of fusion. That one is defined as the amount of heat energy required to convert the unit mass of a substance from solid to liquid state without change in temperature. From solid to liquid state. I repeat, specific heat, latent heat of fusion. Fusion is the amount of heat energy required to convert the unit mass of a substance from solid to liquid state without change in temperature. Now, for specific heat capacity, you see MC theta. While for latent heat of fusion, quantity of heat is equals to ml. So that's for latent heat of fusion. Then another one we want to know here is specific latent heat of vaporization. Specific latent heat of vaporization. This is the energy required to change a substance from liquid state to gaseous state at constant temperature. To change a substance from liquid state to gaseous state at constant temperature. That one is specific latent heat of vaporization. Why specific latent heat of fusion is the one that is capable to change a substance from solid to liquid without corresponding change in temperature. And we say specific heat capacity is the one that is capable of raising the temperature of a unit mass by 1 Kelvin. Please master all this. They are very, very important. Now, I want to make you to understand or take note of this. There is nothing like specific latent heat of fission. There is nothing like specific latent heat of fission. In fact, fission takes a lot of heat, as in gives out a lot of heat. Contains a lot of. So there is not like specific latent heat of fission. What we have is specific latent heat of fusion. Take note of that. Let's continue from where we stopped. So that number 15 says the amount of heat required to convert a unit mass of a liquid into vapor. Liquid into vapor. Vapor at its, it was the one, okay, the amount of heat required to convert a unit mass of liquid into vapor at the boiling point without corresponding change in temperature. That is specific latent heat of vaporization. Specific, question number 15, the answer is specific latent heat of vaporization. And that option is, option A is heat capacity, no. Option B is specific heat capacity, no. Option C is specific heat, latent heat of fission. Specific latent heat of fusion. The option is not there. Let's go back to what we have learned. We said that specific latent heat of fusion is the amount of heat energy required to convert a unit mass substance from solid to liquid. But this one is saying from liquid into vapor. You see, it is not specific latent heat of fusion. Now, specific latent heat of vaporization is the energy required to change a substance from liquid state to gaseous, okay? From liquid state to gaseous. Remember that vapor is gas. So you can see that question number 15, the option is not there. It's supposed to be specific latent heat of vaporization, not specific latent heat of fusion. Fusion will move from solid to liquid, while vaporization will move from liquid to what? Gas, or you call it vapor. So please, let's note that there's no answer for option question 15. We go to question 16. For a simple pendulum, which of the following is correct? This one talks about simple pendulum. I believe that we have a good knowledge of simple pendulum. Though I know that we have good knowledge of simple pendulum, but I want to tell us some things from this question. So a simple pendulum. Let's take this. Simple pendulum is an example of simple harmonic motion. Simple pendulum is a kind of simple harmonic motion. Okay? For simple pendulum, there is a kind of, when it comes to simple pendulum, we have two type of system there. We have two types of system. We have mass spring system. Okay? For simple pendulum, which is a kind of simple pendulum, we have, when you come to simple harmonic motion, let me repeat what I'm saying. When you come to simple harmonic motion, we have two types of system. We have mass spring system. Mass spring system. This is a kind of system that is like this. You know, this system can undergo simple harmonic motion. Then, another system we have there, we have mass string, or you call it rope system. In this type of system is the one you did in your physics lab, where you have something like this. You have a string, or you call it a rope, and you have a mass of ball. But this one, you have a spring, and you have mass solid. Okay? Now, out of these two, the one that is called simple pendulum is this one. Out of these two, the one that is called simple pendulum is this one. Now, for simple pendulum, which is a kind of mass string system, when you come to simple pendulum, the equations you will be needing for simple pendulum, I'm going to still tell us about the one for mass spring system. For simple pendulum, W, which is the angular velocity, is given as root of G over L. That is 1. F is 1 over 2 pi root of G over L. Then we have period is 2 pi over W, which can also be given as 2 pi root of L over G. Okay, so if you observe this, these are the things you need to know about mass spring system, which is also called a simple pendulum. If you want to calculate the angular velocity, you have this. This is the length of the rope, acceleration due to gravity. If you want to calculate the frequency, this is it. This is acceleration due to gravity. This is length of the rope. And with the same thing we have here. So let's go back to the question and see what the question is talking about, or what the question is trying to ask. It says, for a simple pendulum, which of the following is incorrect? W is equal to G over L. W is equal to G over L. Correct. B is equal to 1 over 2 pi G over L. 1 over 2 pi G over L. Root. Correct. C is T equals to 2 pi root of L over G. 2 pi root of L over G. Correct. D is equals to T equals to 1 over 2 pi. Wrong. 1 over 2 pi wrong. So option D is wrong. For W, for F, and for T, for a simple harmonic, for a simple pendulum, which is a kind of mass string system. We have not talked about mass spring system. When we talk about that, that's where you start seeing the spring constant, the mass of the object, and so on. When you get there, we are going to explain that better. When I get there, I'm going to explain that. Let's look at question 17, which it says, which of the following is true? Number one, option A says the vibration motion that is maintained by a restoring free force only is called free vibration. True. Once it is only a restoring force, it's called free vibration. A restoring force. If it goes up, a force will draw it back. It goes up, a force will draw it back. A restoring force is called free vibration. But if it is maintained by a force to all continue, it is now called forced vibration. So for a free vibration, it's a normal vibration. Example now, your simple pendulum, you hold it and you pull it backward and you leave it. It goes and a restoring force will bring it back. It goes back, a restoring force will bring it back. That one is free vibration. It will suddenly still stop one time. A time will come, it will stop. So option A is correct. Option B, when the periodic force is applied to a system, the restoring vibration motion is described as forced vibration. Yes, when a periodic force is added. Now, take example as with the case of a piston in a car. When the car starts, the piston starts making a simple harmonic motion. The engine mechanically enables the piston to continue making this motion without stopping. That's why they said when a periodic force, a force that is being applied at constant time, a periodic force is applied to the system, the resulting vibration is called forced vibration. I remember I said before that when a vibration is going on and you try to maintain that vibration by applying a force to keep it going, it is now called forced vibration because you are forcing it to continue. On its own, it doesn't want to continue. So it's called forced vibration. Option C, for a vibrating system that the effect of friction can be neglected is known as undamped oscillation. Yes, you know that when a vibration is going on or a simple harmonic motion is going on, it will definitely come to stop. Why? Because of frictional force. So if you know that there will be frictional force, you will know that one time after a certain while, that motion will stop. But if you don't know that there is frictional force, if you neglect, okay, let's neglect that there is no frictional force, that motion will not stop. It will continue because the only thing that will stop it is what? Frictional force. So that's why the question says, for a vibrating system that the effect of friction can be neglected is known as undamped. What do we call damped oscillation? Damped. Now, a damped oscillation is an oscillation that comes to stop. Example, you look at something like this. This is an oscillation. If it comes to stop, it's damped. You closed a bar and it's a door bar, it stopped. So that one is damped. But what causes this damping? Frictional force. If you neglect frictional force, that means you are assuming that there is no frictional force. Then it will not damp. It's just like this, your simple pendulum. Once you move it, it will be moving continuously like that. Then frictional force from the environment will start acting on it. After a while, if you come back, you see that it has stopped. But if you neglect frictional force, it will continue. So option C is correct. Option D says when the effect of friction is added to a system, the vibration is termed undamped oscillation. No, when the effect of friction, if you now consider friction, then it's going to be called damped oscillation. Do you understand that? If you consider frictional force, then what you have is damped oscillation. But if you neglect frictional force, what you have is undamped oscillation. I believe I've made that question clear. Number 18, acceleration of a simple harmonic motion is given as, okay, we need to know something about question number 18. Like I said, there is something I want us to learn about that question number 18. Let's see why our answer is going to be. Now, W is equals to T, which is equals to KE, where T is equals to K into E plus extension, Hence, T becomes KE plus KX, where W is equals to tension, weight is equals to tension. Now, F is equals to W minus T. Remember that W is KE, while T is KE plus KX. Okay. Now, if you observe that now, KE minus KE minus kx. So you will now see that therefore F becomes, this cancels this, F becomes minus kx. That F becomes minus kx. This is true for a simple harmonic motion, that the force is equals to minus spring constant times the displacement x. So force. Why is this minus here? Because it's always a restoring force. It's a negative force. So F is equals to minus kx. Note this. Now, remember that F is equals to ma, normal. Then, do you know that A is second derivative of V? If you differentiate velocity, you have acceleration. So V will be x1 dot, while A be x2 dot, second derivative. So anywhere I see A, I can put x dot dot because it's a second derivative. Therefore, I will now have that F is equals to mx dot dot. That is second derivative. Now, I now have that F is equals to ma. That is ma, which is m second derivative. And also have that F is equals to minus ke. Hope you know that. Minus kx. Here is minus kx. So follow me down here. So I will now have that F is equals to mx is also equals to minus kx. Hence, mx is equals to minus kx. Bring in this guy. We have mx plus kx equals to 0. So make the second derivative x the sort of the formula. You are going to be having minus kx over m. So master this for that question number 18. So question number 18 says acceleration of a simple harmonic motion is given as minus kx. That should be option minus kx over m. Option D, minus kx over m. Option D. So we should note that very well. Now, question number 19. Impulse of a force is equivalent to, remember that impulse is equivalent to momentum. I hope we have not forgotten that. Impulse is equivalent to momentum according to Newton's second law of motion. That impulse is equals to momentum. The whole of this is called impulse. Why the whole of this is called momentum? And this is Newton's second law of motion. Okay, that is question number 19. Look at question number 20. A force of 20 Newton is applied to an angle of 40 degrees above horizontal to a block that slides across the surface. How much work is done? Work done. Always know that work done is equals to FD cos theta. F is the force, D is the displacement, angle of displacement, FD cos theta. So if you watch that option, it gave us a force of 20 Newton. We have already gotten value for F. It's applied to an angle of 40 degrees. We have got the value for theta. So it's going to be cos 40. Above the horizontal to a block that slides across the surface. How much work? We are looking for W. How much work is done in moving this block around a distance of 35? D becomes 35. I believe that question is well understood. That question is well. Let's see the quiz for that year. He said elastic limit is the load or stress dash. Elastic limit. Elastic limit. If we look at the diagram on the board, this is a graph of load against extension. If you look at OA, it's called the elastic region. It is the region at which the material returns to its original shape and size when load is removed. Between here and here is the elastic region. Then at this point A now is called the elastic limit. Point A is called the elastic limit and is defined as the load or stress beyond which the material becomes inelastic. The load or stress beyond which the material becomes inelastic. The load or stress beyond which the material becomes inelastic. Then the point B says is the yield point, or you call it the ultimate tensile strength. It is the point from which the material enters plastic stage. It is the point from which, okay, please, Point A. Point A. Let me repeat. Okay. If we look at the diagram on the board, it is a diagram of load against extension. So this question from between OA is called the elastic region. It is the region whereby if you remove the load on the material, it goes back to its original shape and size. Then at point A, it is called the elastic limit. The elastic limit. This is the load or stress. This is the load or stress from which the material enters becomes inelastic. This is at this point now is called elastic limit. This is the limit. From this point, if you exceed this point, it will enter, the material becomes inelastic. So if you move away from here, beyond which the material becomes inelastic, then B is called the yield point. The yield point. It is the load or stress from which this one is beyond which, where this one is from which the material enters plastic stage. This one is the point from which the materials enter plastic stage, while this one is the point beyond which the material becomes inelastic. While D is called the breaking point. D is called the breaking point. So let's see what the question is saying there. It says elastic limit, okay, is beyond which the material becomes inelastic. Correct. Beyond which the material becomes inelastic. Question number 2, there's a blood pressure is, that one is talking about. Looking at question 2 there, we need to learn some things about blood pressure. So we have factors affecting blood pressure. Cardiac output. Blood pressure is directly proportional to cardiac output. That means if blood pressure increases, cardiac output will also increase. We have blood velocity. Blood pressure is directly proportional to blood velocity. We have total blood volume. Blood pressure is directly proportional to the total blood volume. We have blood viscosity. Blood pressure is directly proportional to blood viscosity. There's other things I want us to learn about blood pressure. Note, blood pressure is the maximum. Blood pressure is maximum. That's, it will be at maximum. And the maximum is called systolic. Systolic. We repeat. Blood pressure is at maximum when the ventricle contracts, and it is minimum, which is called diastole. It's at maximum. That is systole, when the ventricles contract, and it's at minimum, diastole, when the ventricles does what? Relax. Hence, blood pressure is the difference between the systole and the diastole pressure. Blood pressure is the difference between the systole and the diastole pressure. Now, normal blood pressure is rated 120 to 80. Normal blood pressure is rated 120 to 80. That is why if you go for your blood pressure, you want to see whether you have high blood pressure or low blood pressure, whichever one that you are asking them whether you have. If they want to tell that, oh, your blood pressure is normal, it will be 120 over 80. That is systole over diastole. Your systole should be 120, while your diastole should be 80. Then it is a normal blood pressure. Now, also know that blood pressure varies with height. Blood pressure varies with height. Hence, the best standard reference point for measuring blood pressure is the upper arm, which is at the same level with the height. The heart, sorry. That is why if you want to measure blood pressure, you do it with the upper arm. It varies with what? Height. Blood pressure varies with height. Okay. Another thing we need to know there is that the heart pumps blood in strokes. The heart pumps blood in strokes. The number of strokes per minute is called the heart rate. Boom, boom. That is what we call the stroke. It pumps blood in stroke. The number of stroke you have per minute is called the heart rate. The volume of blood pumped per stroke is called stroke volume. Volume of blood pumped per stroke is called stroke volume. Now, and the last thing we need to know there is cardiac output. Cardiac output is the volume of blood pumped per minute. Cardiac output, the volume of blood pumped per minute. Mathematically, cardiac output is equals to heart rate times stroke volume. Heart rate times stroke volume. Heart rate times stroke volume. These are the information we need to have about blood pressure. We look at the next question. Question number 3. Which of the following is not a fundamental quantity? That is elementary. Fundamental quantities, they are 7 in number. I suppose you know them now. Why the fundamental quantities are 7 in number? Why the derived quantities are many? So the fundamental quantities, we have Lucan must take the ultimate element. So we have length, luminous intensity, mass, temperature, time, ampere, and electric current. So you can now fish out that. Question number 4. The total rate at which a black body emits radiation is proportional to the fourth power of its absolute temperature is known as Stefan's law. It's known as Stefan's law. Let's see some things about Stefan's law we need to know. It's known as Stefan's law. I read. Stefan's law or Stefan Boltzmann's law. I want to state Stefan's law. Stefan's law states that the total rate at which a black body emits radiation is proportional to the fourth power of its absolute temperature. I repeat, Stefan's law states that the total rate at which a black body emits radiation is proportional to the fourth power of its absolute temperature. Hence, according to Stefan's law, E is directly proportional to T raised to power 4. If you remove the proportional sign, you bring in E is equals to this T raised to power 4, where this guy is called Stefan's constant. This guy is called Stefan's constant. Now, however, if the body is not a perfect black body, then E is equals to this. If the body is not a perfect black body, if it's a perfect black body, then E is equals to Stefan's constant times 10 raised to power 4. But if it's not a perfect black body, then E is equals to, we have this, where this guy is called emissivity, ability to emit, emissivity, okay. Now, we have said that a black body is a body which absorbs the entire heat radiated, incidented on it. It is perfect, it's a perfect absorber or a perfect what? Emitter. So this is what we call Stefan's law, because that question was asking us something about Stefan. It says the total rate at which a black body emits radiation is proportional to the fourth. Total rate at which a black body emits radiation is directly proportional to the fourth. Okay, directly proportional to the fourth power of its absolute temperature. So it is called Stefan's law. It can be called Stefan's law, or it can be called Stefan Boltzmann's law. But if you watch this option, we have Stefan's law 1, Wayne's displacement, no. Boltzmann, it can't be called Boltzmann's law. Instead, it will be called Stefan's Boltzmann's law. Let's look at question number 6. Question number 5. Which of this is not correct? The time interval required for the system to complete a full circle is known as its period, with unit as second. Time interval to complete a full circle is period, correct. The maximum displacement from the equilibrium position is the amplitude, with unit as meter. Very correct. Amplitude. Remember amplitude. If you have something like this, this is the maximum displacement from this is equilibrium position. Maximum displacement is called what? Amplitude. That one is very correct. The maximum displacement from that's the number of complete circle in one period is called frequency. That is option B, with unit as x. Option A is correct. Option B is correct. Option C is correct. Then option D, a simple relation exists between period and frequency, and it is given as no. Relationship between period and frequency is that frequency is equals to 1 over period. Finish. Any other relationship does not work. So option D is wrong. Question 6. The following are vector quantities except what are vector quantities? Quantities that have both magnitude and what? Direction. Let's see. Displacement. Distance is a scalar quantity. Why displacement is a vector quantity? Velocity is a vector quantity. Speed is a scalar quantity. So speed is not a vector quantity. Force is a vector quantity. Let's look at question number 7. What type of energy is in a burning wood? What type of energy is in a burning wood? It's not mechanical, it's not a chemical energy, it's not a kinetic energy, it's not a fire energy, it's called mechanical energy. Number 8, a body experiences weightlessness in space due to what? Lack of gravity. Due to lack of gravity. When there is no gravity, you will start experiencing weightlessness. That is just it. If you watch those that goes to the moon, the astronauts, when they are there, they are floating. There is no friction, there is no gravity there. So they experience weightlessness because of lack of gravity. So lack of gravity, option D. Number 9, a 500-gram car moves with a velocity of 20 meters per second. What is this momentum? Now, a 500-gram car, they gave me the mass of the car to be 500 grams. I'm going to convert it to kg by saying 500 grams. Remember that 1,000 grams is equals to 1 kilogram. So 500 grams will become x. X becomes 500 over 1,000. We put this thing in what? Kilogram. So 500 over what? 1,000. This will cancel this. This will cancel this. We have 5 here, 2 times, okay, 5 here, 1, 2 times 5 is 10. So I have 0.5 kg. So we have converted mass to kg. He said a 500-gram car moves with a velocity of 20 meters per second. Its velocity is 20 meters per what? Seconds. In answer, I should calculate the momentum. Remember that momentum P is calculated as mass times velocity. So we have 0.5 times 20. Whatever you have becomes the answer there. Okay. Number 10, the velocity of a car increased from 4 meters per second to 9 meters per second in 0.2 minutes. What is the acceleration? Very wonderful question, and which is the last question for 2020. It says the velocity of a car increased. That means the initial velocity U is 40 meters per second, while the final velocity is 90 meters per second. Then we were given time to be 0.2 minutes. You are going to convert this one to seconds. So remember that 60 seconds make 1 minute. So how many seconds will give me 0.2 minutes? We cross multiply. That means we have 60 times 0.2. So this one will be 60 times 0.2 will give you in what? Seconds. So the question says we should calculate acceleration. Remember that uniformly accelerating motion, that A is equals to V minus U over T. So I'm going to be having V 90 minus 40 over 60 times 0.2, all in seconds. So whatever you get there becomes the answer for that question. And that brings us to the end of the first year, which is 2020-2021. So we are going to be moving to the next year, 2021/2022. Thank you. Ensure to post your comment on the comment section on this YouTube page. And also don't forget, like and subscribe to this page. Thank you and God